There is a question in front of you. This is a very good conceptual algebra question based on logarithm. We have to find the sum of roots. Before watching the solution, pause the video and try the question yourself. Even if you cannot solve it completely, try to identify the first step. I hope you have tried. Now let us solve it from the basic concepts. Before starting, look at these 4 logarithmic properties in front of you. We will use the power rule, the addition rule, the subtraction rule, and the change of base rule. You do not need anything beyond these 4 basic ideas. Our first target is very simple. We want to cover every logarithmic into the same base, and that common base will be 3. Look at the original equation carefully. The first term is x plus 1. Since log base 3 of 3 raised to power x plus 1 is simply x plus 1, we can write this term also as a logarithmic of base 3. Now look at the last logarithmic terms. It's base 9, but 9 here is 3 square. So using the change of base, 2 log base 9 becomes 1 log base 3. And in the middle term, the 2 multiplying the logarithmic can be taken as a square inside the log. So now every term is written using log base 3. That is the first important step. Now all 3 logarithmic have the same base, so we can combine them. The first and the third logarithmic are being added, so their expression will multiply, because when we add the 2 log terms and log taken out, it's multiply. The middle logarithm is being subtracted because it is minus, so the expression will come in the denominator. Minus becomes divide. After combining everything, we get one single log base 3 equation to 0. Now remember one basic fact. Log base 3 of 1 is 0. Therefore, our logarithmic is equal to 0. The expression inside the log must be equal to 1. So now the log are completely gone. We left with an ordinary algebra equation. Now look at the equation. We have 3 raised to power x appearing again and again. Whenever the same exponential expression appears again and again, a substitution can make equation much easier. So let t is equal to 3 raised to power x. Then 3 raised to power minus x becomes 1 divided by t. And 3 raised to power x plus 1 becomes 3t. Substituting these values, our equation becomes 3t multiplied by 5 minus 1 by t is equal to t plus 3 whole square. Now simplify both the sides. The left side becomes 15t minus 3 and the right side becomes t square plus 60 plus 9. Bringing everything to the one side, we get t square minus 9t plus 12 is equal to 0. So the logarithmic equation has now becomes a simple quadratic equation. Now this is where the real idea of equation begins. We can solve the quadratic and find both values of t, but hold on. But the equation is not asking for the individual roots. It is only asking the sum of original values of x. So solving the quadratic completely is unnecessary. Let the 2 roots of the original equation be x1 and x2. Since t is equal to 3 raised to power x, so the 2 roots of the quadratics are 3 raised to power x1 and 3 raised to power x2. Now use Vieta formula, that is the relation between the coefficients and the values, for a quadratic. T square minus 9t plus 12 is equal to 0. So the product of roots is 12, c by a. Therefore, t raised to power x1 multiplied by t raised to power x2 is equal to 12. When the power of the same base is multiplied, the power is going to be added on. So we get 3 raised to power x plus 2 is equal to 12. Now convert this exponential from the back into log again. Therefore, x1 plus x2 is equal to log base 3 of 12, and that is exactly what the question asked about. This is what we have to find. So the answer is log base 3 of 12. I hope you have understand the concept. Now there is a similar question in front of you. This time, try to solve it without watching any solution. Remember the flow. First, make the log base same. Second, combine the log. Third, substitute for the repeated exponential terms. And finally, use Vieta, which is the coefficient and the roots relationship of unnecessarily solving the quadratic equation. Pause the video, solve it, and tell me your answer.